Hey, happy Friday, everybody. It's the weekend tomorrow, so hopefully I'm the only thing standing in between you and that. And so it's an honor to be here for Engineers Week. It was in my intro from Joe. Thank you for that. And Samantha, thanks for getting us ready. I'm a professional engineer, licensed in the state of Florida. I have a civil engineering degree. And then I'm going to talk to you about robots. So I guess the big idea here is life comes at you fast, right? So whatever you think you're doing now, prepare for change. So I'm going to pivot just a little bit from getting right into the presentation. We're going to talk about autonomous vehicles and artificial intelligence and some cool stuff. But maybe I'll make it a little more personal right out of the gate. Is when I went to Georgia Tech, they were talking about computer science a lot. It was a top 3 major. That was, I started in 2000, graduated 2005. They were talking about this coming wave of technology disruption. And I did my best not to listen to any of that. Because by damn, I was going to be a civil engineer, just like my great uncle who went to Georgia Tech and graduated in 1953. And so I didn't need to worry about controls and computer science and circuits and signals. I just needed to know about concrete. And so I always tell people with civil engineering, there's only a couple rules, okay? When it's gray, it's hard, okay? Don't do anything with it before it turns gray. It's a concrete joke if you didn't get it. Water flows downhill, okay? The city of Houston did not get the memo, right? So now, and then if it's moving, you have failed. Okay, that's civil engineering. So you guys are basically all professional engineers now. Related to civil engineering, I got a couple mentors in here. So Kevin Crump is sitting at the front table up here. He's representing Haskell here. And he actually signed my PE application way back when I had to send one into the state and I needed somebody to vouch that I had accumulated enough experience to become a professional engineer. Another engineering mentor of mine sitting at the other front table, which is Cheryl Freeman. Cheryl is kind of one of those quiet success stories here in town. If you have driven on a highway in Jacksonville and it worked, you owe Cheryl a debt of gratitude. So she was basically, I call her the city's project manager when they did all of the expansions of the highways, 9A, 295, the downtown interchanges, and all those different projects never would have happened without dedicated engineers like her making it happen. So appreciate both of those, and so I'll just make sure I hit this right up front. Who's a student here? Where are our students? Okay, well, thank you guys for being here, and as you're preparing to, the rest of your future at UNF, and then eventually life beyond that, make sure that you have your eyes kind of focused on who could be potential mentors for you. I've got 2 mentors that I did not expect to be in the room here today, right here. And without people like that, I wouldn't have my body of knowledge. So I just want to make sure I hit that for all you younger people and students, is that this is a trade that you're in where you get knowledge from the smarter people that went ahead of you. And so make sure that you're finding those people and that you really have an attitude of kind of learning and servant-mindedness when you're working with those people. Okay, so enough about that. We're gonna jump right into it. So as I said, life comes at you fast. I used to design and build buildings. And now, a couple years later, my company here, based here in Jacksonville, is one of the leading autonomous systems engineering companies in the world. And I just say one of, to be humble, we might be the most, because no one else does it yet. It's super early in the field. You hear a lot about driverless things, but right now everybody's focused on the unit. I want to make a driverless car. I want to make a drone that flies by itself. People aren't really yet in the mindset of trying to create systems that work together so that things happen autonomously. So I'm going to just kind of get you guys up to speed with where the industry's at. So the first thing we're going to do is look at on-road. These are categories that are basically out in front of you. If you stay touched into like Forbes magazine or something like that, you'll see a lot of articles. For those of you old enough to have a LinkedIn account, you'll see a lot of articles like that. So students, if you don't have a LinkedIn account, start thinking about it. So you've got this last mile e-commerce, artificial intelligent, self-driving bot. These are super popular in places like San Francisco. I don't know how functional they are yet, but the companies doing them are putting a ton of R&D into it, and they're getting a ton of investment. So investors are investing billions and billions of dollars into getting goods like groceries delivered to your doorstep or your curbside. The next one is the robo-taxi. Google is pretty much leading the way in robotaxi. They have been certified to run in San Francisco and Phoenix. So they're driving autonomously to deliver people just like Uber. So if you're in San Francisco or Phoenix and you look at your Google Maps, you have an extra button that says, do I want a robot car to come pick me up? We don't have that here yet. The company Cruise just got certified for their first robotaxi initiative. So that's something that we've been hearing about for almost 10 years. People used to say your kids won't drive. You know, that shows you how bad futurists are at predicting. The kids are driving, but it is happening. There's signs of progress. And then finally, right here in Jacksonville, we have the largest mass transit autonomous project in the nation. So that's a cool thing. And that project has started this year. So they're starting construction on what has to happen with the roadway, and they're going into procurement and testing with what has to happen with the vehicles. So that's Jacksonville's very own, and that's one way that this area is leading the nation. Okay, the next I want to show you is off-road. So when you're on the road, you have a constrictive, what's called ODD, operational design domain. That means I have to be worried about pedestrians. I have to worry about kids on skateboards if you're in Jacksonville. I have to be worried about people that have disabilities and less than ideal mobility getting on and off vehicles. That's super hard to design around. I have to worry about other drivers. Once I get off-road, the rules are a little different. So I got a couple videos here so you can get context. So probably the most famous autonomous robot is Spot, the robot dog. Spot can see and navigate for himself or herself. And all right, hey Danielle. And so Spot can do things like go through doors and go up staircases. And that's a pretty wild set of artificial intelligence for navigation, to be able to understand that I can leave the sidewalk and go through doors. This is like really how the world around you is about to start to change without you fully knowing it. And so this is an example of autonomous farming. And so I'll kind of talk ahead of the video in case it doesn't catch up. This is basically the idea that agriculture can happen without somebody having to do it. You know, immigration is a big talking point in this country. Food security is a big talking point in this country. Somebody explained to me why all the lettuce that we're eating here comes from California and Arizona. They have no water. Look outside. We're loaded with water. So what's up with our supply chain that we have to do this farming and this unsustainable type of stuff in places that are least suited for it ecologically? So autonomous farming really starts to move the needle there. It starts to solve a lot of problems around labor, and it starts to solve a lot of problems around predicting crop yield. That's something that right now there's no science on. So we'll skip ahead and just imagine that that tractor was moving. The next one, this one is super fun. This is what it looks like, I guess, when a bunch of students start making driverless vehicles, right? It's like really fun vehicles that can do really wild stuff. And the reason I had this video selected is it's like doing wheelies and it's spinning out and things like that. And it kind of just shows you what is possible with current state technology. Where is the technology of vision system and artificial intelligent navigation right now? And the short answer is you can do whatever you want already. The industry is there. There's 10 years of solid research in the field. Now the question is, how are we going to apply it? And for the students, how are you going to apply it? Okay, so we'll get off of the off-road, and now I'm going to show you basically where the industry makes sense. This is what's happening right now that has commercially valuable application. So far up until now, nothing makes profit. Oops. All right, so we're going to go inside of facilities. And I'm a factory automation guy. My colleague Kevin over here, he's a factory guy. He designs and builds factories for a living. So we are all US manufacturing all the time, made in America. But the problem that we have is there's a bit of a broken paradigm. To make things in America, it has to be extremely automated. Because you're competing with low-cost wage centers overseas, you have to put in process automation, packaging automation, material handling automation, which is super expensive and not that many people know how to maintain it or use it. So one of the things we're trying to do is take all these little pockets of robots and pockets of automation that already exist in factories, and we're trying to connect them into a network of automation. That's basically our design theory. And so just 2 quick case studies, just to give you a sense. We just finished 2 projects. They're like, one of them's a 1 million square foot project, so about the size of the Amazon box up by the airport. The other one is 700,000 square feet. And both of them contain the largest fleet of autonomous robots in the world for their category. Now, I'm disappointed to share with you, one is in South Carolina and one is in Tennessee. And the call to action that I guess I'll issue to you here is, why the heck aren't they here in North Florida? And so that's something that, when I have the chance with the chamber and city leadership I address, is why are we not doing the next generation greatest thing right here? We have the smartest people, we have the land, we have the institutions like UNF willing to support it. Now we just have to get the kind of all the forces in line so that these great things aren't happening in South Carolina or Tennessee. We know they're not as smart as we are, so we need to bring it home. So let's see, we'll jump over. What are our design considerations when we go to do this? So number 1, financial. Like, businesses don't do things if it doesn't make money. That's number 1. So even if you didn't take a finance class yet, take one on YouTube or something. If it doesn't make money, it's not going to happen. So on the left, we look at some of basically the business case around why autonomous robots work. I'll jump to the point is, autonomous robots are 1/10 the cost of people moving things, and they're 1/5 the cost of forklifts moving things. So if you go into any facility and you see people moving stuff around with their arms and legs or forklifts, we have a cheaper way. And why is that important? Their great resignation. There's not a business in America right now that can staff fully for all their open positions. So we need to find a way to offset the labor. And that brings us over to the right-hand side, which is, now that we're trying to offset labor, what's our biggest thing? It's cobotics. The idea of collaborative robots. We want the robots to work with humans to make the human's life easier. Doing repetitive motion and repetitive lifting is one of the biggest challenges to staffing a job right now. It's why the jobs where you get dirty and sweaty are just super hard to staff right now. So we want to make it where when you have a tough job, a robot's helping you with the lifting so that when you go home, your back is not sore. So we're very focused on ergonomics. Okay, so I talked about what it is. Let's see if this video will go for us. This is what it actually looks like. On the left, you see a prototype robot. That's something that my team designed and built. Why? Because it didn't exist. We had an autonomous robot, but the robot didn't have tooling applications to be able to actually move the things that we wanted to move. So we built some little prototypes. You could almost picture that if that was 2 buildings over here. You could build some little prototypes. How did the things talk together? IoT. We built some Internet of Things communication devices. We call it Bluetooth handshakes. So we started using super rudimentary basically technologies that you already have and just applying them in a new way. The item on the left is patent pending. Why? Because like I said, nobody's done it before. So one of the reasons I'm showing this to you guys here right now is because as you're entering your career field as students, this stuff is just starting. There's a long runway and plenty of green space for you guys to get in there and kind of make a difference. So see if I'll just skip through this video since it's super slow so you can see some of the different applications. This is an example of a fully automated forklift. It must be somewhat precise because it's navigating an entire factory, and then it's going to find a way to take those 2 big fork prongs in front of it and put them right in the perfect place to go perform its mission. The reason I'm showing you different vehicle types is because one of the biggest design theories that we have is around what I call mixed fleet. So we want to take different types of vehicles and use them for their correct purpose. Think of the roads out on the street. You got tractor trailers, you got buses, you got cars, you got motorcycles, you got a lot of different types of vehicles working together with human drivers. As we move into the autonomous space, we're going to need a mixed fleet of different form factor vehicles. Let's see, there's some tooling, and I'm just going to get out of this because it looks like our internet Wi-Fi has crashed here on campus. And this is the computer side. This is basically the fleet management of what it looks like for us to create software systems that can take all this sensory input from driverless vehicles, their laser vision, and aggregate that to where we're starting to get some level of mission control. Because basically, we don't get to tell these autonomous robots what to do. They're autonomously figuring it out. But we do kind of like talk to them like you might if you had a fleet of drivers all working over radio, and we tell somebody what the next mission is, what their next thing they have to do is, or if they ask a question, we can respond to that. All right, so I'll jump out of this. And then this is like one slide that's just busy. It's in case we have some people in here that are a little more techy and nerd-minded. These are all the things that you need to make an autonomous robot system. So I'm not going to read through them all, but essentially on the upper left, that's the drone head. What is the drone head? It's the driverless package. You know, it's what Google has in their cars that makes it so special. It's vision and thinking systems that work. The next is, what's the biggest cost in these things? It's actually the steel and the lithium-ion batteries that make it work. With everybody, you know, who saw the Super Bowl? How many driverless car company or electric car companies did you see advertised during the Super Bowl? There's a lot of competition for these scarce resources. And we already know like all this lithium-ion type battery storage is super scarce from a mineral perspective. How do we make it work with other systems and people, the tooling and the manipulators? So we have to really be intentional about how we think about that. Down in the bottom right, how do we get past a unit of one? It's the software. So the software is the critical thing that gets us past a unit of one and gets us into kind of a symphony effect of a bunch of different robots. And down here on the bottom left, all this is great, but who are we going to tell about it? And if you don't have multiple ways to communicate, you won't be effective, especially because you're going to be sometimes outdoors, you'll be off-road, you'll be on-road, you'll be in factories. So we need to have really robust communication systems. So anybody in here that's into kind of communications or signal processing, you're going to have an amazing career ahead of you, because most of the communication systems we're going to be using in the future you don't even know about today. And so if you could go back in time just 10 years ago, were you thinking about Bluetooth? Were you thinking about 5G? Were you thinking about Wi-Fi that most of the time worked? And so now look at where we are today, right? The world has changed, and that pace change is going to keep moving just as fast. So that's basically it. I wanted to make sure you guys saw the present state of autonomy. This is current as of probably the beginning of this year. So it's about, this snapshot's about 4 to 6 weeks old. You know, basically on-road, there's encouraging things, but you're not going to see it for a while, especially here in Jacksonville. Off-road, it's already there. There's a bunch of advanced applications like mining and other off-road things. Certainly the military is investing heavily in this for warfare and some of their operations. And then in facilities, it's already happening. There's already boots on the ground. There's already full autonomous systems performing manufacturing and e-commerce in the states around here. We just need to get it here. So with that, I'll take any questions if you got, and Samantha, cut me off on time when we're ready.
Matt, I got a question. If you can you speak to the present state of how the city of Jacksonville is planning on retrofitting the Skyway for autonomous vehicles?
Yeah, thanks. So that's about the Jacksonville Transportation Authority driverless car project is the question Kevin asked. I was the technology designer for that, so that was super fun. It took me about 3 months to do the design, and then it took 2 years working in City Hall to explain it to people. So as engineers, get ready for that, right? Communication skills are a huge part of it, especially for non-techies and people that aren't really ready to change. So basically, they're going live with the first part right now, Kevin. So the way that one happened is we came up with an innovation design that said, this is really going to move the needle for public transit, but it's not so scary that the government should run away from it. You know, we know big tech says fail fast. Government says fail never. And so the bureaucrats that were making the decisions really needed to have a game plan that felt safe to them. So the magic about JTA's plan is they have a 4-step process to get to their final state of technology. So, and the starting point is with commercially off-the-shelf driverless stuff like I just showed you. In the future, it's going to be pretty wild, and it will be like the Waymo stuff that Google's doing where it's on demand and it's on your phone and it's coming to you. But we weren't going that far on day one. And then the next part was getting stakeholders with money. So Jacksonville was successful in a competition of 700 cities, municipalities, and states. Jacksonville was one of only 2 winners for the driverless car grant. It was Jacksonville and Las Vegas. So they got $25 million from the feds. At the time, the governor of Florida made an easy promise. He said, sure, if you guys get it, I'll match it. Because Jacksonville's not going to win. So then when Jacksonville pulled off the upset, and they were kind of the belle of the ball, suddenly they had federal money and state money. And if you pay attention to what happened in Chamber, it was towards the end of late last summer, Jacksonville funded 2 strategic initiatives for the city. One was the driverless city bus project, which we're talking about, and the other was the Emerald Trail Bike Zone. So the city said we're going to be very intentional about being bike friendly and pedestrian friendly and moving to an innovative autonomous transit state. Does that get the question, Kevin? And the project just started, so, yep. Anybody else? Students, come on. Especially if I know you.
So in
Go ahead.
terms of the Las Vegas project, how does that differ from us? I know they have a monorail system that is probably way more functional and people actually pay to ride. So how are they implementing their award?
Theirs is doesn't recycle the existing assets. So the challenge with the Jacksonville Skyway is supposedly it's worth like $300 million. Okay, and then if you decommission it before it's finished being used, you're supposed to repay the federal government for the unused part of the life cycle. So that's one of the main reasons you don't see it being torn down. In Las Vegas, they made a different decision. Theirs kind of works. I mean, if you've been to Las Vegas and rode the monorail, I mean, it kind of works, you know. I give it a C. It'll get you there if you stay at the exact right hotel and you're going to the convention center. If you're doing anything else, you're taking a taxi on the strip like everyone else. So, so what they're really focused on is getting on-road autonomous shuttles that go to their old city district, like the old strip. And it's pretty neat what they're doing, but it's also, it's a huge step behind what Jacksonville's doing in terms of technology complexity. Jacksonville's is trying to make this a system that works for 20, 30, 40 years. The Las Vegas one, and I hope nobody in here is from Las Vegas, is theirs feels like they're just trying to show that vehicles are moving. That's literally what it looks like to me. So I don't see that they have a long-term plan to continue to step up the flexibility and make it part of a regional transportation plan. Anyone else?
Have you worked with the Jax Port about automating any of their systems?
The Jax Port?
Yeah.
Not directly. So the question is automating Jax Port. I did help them with some technology concepts a couple years ago. And the summary is, at the port, there's 2 different issues. One is land. They don't have the right land configuration for innovation. Savannah does. Savannah has basically a tenant port, and so the Port of Savannah controls what's happening. They have a master plan. In Jacksonville, the parts of the port are divided up, the land area, and there's not really a master plan. So the first piece I see for opportunity in the port is for e-commerce. There's no reason we're not crushing it in e-commerce at our port, other than the way the port is configured from people that have the land and then park a bunch of cars there. You know, whenever you take a bridge, you look down, you'll just see a zillion cars parked down there. Now, relative to cars, there's actually brand new technology that's available where you can do dense storage and automated movement of cars. And I think that's the next zone, is to basically, if Jacksonville is going to be a successful car port, let's get, you've all seen Carvana on like JTB and 95, right? Let's essentially get a more functional system, a version of that can hold thousands of cars, that's going to automatically unload these cars from ships and then store them densely and then bring them out in the exact order that they're needed for transport. And that would dramatically increase our storage capacity. Right now, they're just single parked all over the port, and it's taking up all the space. Anyone else? All right, super. Well, guys, thanks for having me. And young engineers, you know, start studying for your FE. Don't wait. That's my closing advice. Thanks, guys.